Hello guys and welcome back to 737 DIY Sim here in the UK. Now, I've been away for a little while. I've been to the expo back in the US. We've come back, we've moved into a new location and we've finally got version 3 of the FMC ready. Now, this has taken a serious amount of time to get to this standard. The whole idea was to make a version just like the MCP DIY version where everybody in the world could make it. Well, version 1 was like that, and this is version 1. If you remember back all those years ago, completely 3D printed and hand wired. And just recently I took it back out of the 737 SS behind me here, and I'd forgotten what a nightmare that would be for people to design, to create now as a beginner. You know, hand wiring every single switch and LED. Well, I guess it's part of my trade and I just got on and did it. Version 2 came out shortly after, and version 2 was the version 1 frame here, but with cockpit sim parts buttons. So they worked out really well. Laser engraved buttons. It changed the look of the front unit drastically. Also, we split the screen top and bottom. So top and bottom, so anybody could print it on a resin printer. That was the whole idea. Made it much quicker to print, and of course the finish, if I just get in close, the finish is absolutely perfect. Now, I'm actually showing you version 3. That's this version here, the latest version, but the basic shape, the basic size and design is still the same. It's just that I don't have a resin version to show you from version 1. Version 2, as I said, now version 2 also used a PCB, not from my design, but from my moderators on the Discord channel. We've got Roderick and his co-workers all designed the PCB, but it was all SMD built, and even Roderick admits that, you know, trying to keep up with the sheer amount of people that were building it and then having issues. He just basically, as one man, couldn't cope with the amount of work. Now, that's where I came in, and I've been meaning to do this for a long time. And that was to create a PCB. Here we are. Now, I've got to say I'm pretty proud of this because of what it's achieved. This build that you're about to witness now, about to proceed or do and hopefully follow, allows you to create this unit that looks absolutely stunning. Let me get that close cam there. Now, a massive shout out to Prosim 737, who have given me the software to display and demo. Not only have they given me the software for the 737 single seat here, but they've also given me the version for the Max. And the reason they gave me that was so that we could build a 737 Max single seat and show off their software at the same time. So as you can imagine, there is now lots to get on with. Now, don't worry if you don't want to buy Prosim 737 because it is an expensive bit of kit. This unit does work with PMDG with one button press using Mobiflight. That's special thanks to Bram, a moderator on the Discord channel. And we've got Andrea, who developed the software for the X-Plane using Mobiflight as well, but he put all the configs in, and again, that's one button press. I won't show the X-Plane download, but I will show the PMG programming later on. And we've gone to town on this, and it really is just load the Mobiflight config file up and it should work straight away for both Prosim, PMDG and X-Plane. What makes this build so special is the PCB that I've designed. So there are only 6 wires to connect to the board, and we'll go through that in a minute. All the components are already on it. We basically just attach our 3D printed components onto the front, put the buttons in, screw it together, and we are done. The PCB, as I said, has 6 wires only to connect, and we'll talk through those in a minute, but it's got all the LEDs installed. So we've moved away from these LED tactile switches. Now, the reason why we moved away from them is because, as most people know, the button throw, the button movement, or the button press, is very slight. We're talking 0.5 millimeter. Now, we go to this new PCB, and we're using the high quality AUX buttons that have soft press plenty, I think they've got 1.5 millimeters worth of movement, which is loads. So you've got that distinctive press as it goes in. Let me show you on the real unit here. Let's put, we should see the A arrive at the top here. There we go. And you can see how far that button is moving. And it's a nice distinctive click and soft press. Let me just clear that line. There we go. While we've got it this close as well, you will see, thanks to Prosim, that we can now move every single line to line up with the buttons, no matter where they are. That is one of the benefits of Prosim, which we can't do in PMDG. Now, another benefit to the PCB is that the Arduino, that's this part of the board here, and all the shift registers, input and output, are all included in the board. It's actually not an Arduino, it's a Raspberry Pico, but that just enables now a USB data cable to be attached here and power in here for the LED lighting, which we'll do that in a second. Now, why have I used a USB cable instead of a USB connector? Actually, there's several reasons for that. And as you can see, this unit needs to fit in probably many different cases. We've got the desktop angled unit here. We've also got the flat straight case here, so it can go on your desk flat. Also, we've got the 737 single seat EKIS module case there that needs to fit into, and I didn't know where the best place to put the USB port on. So what enables maximum flexibility is a cable that can be bent and located in any direction. Hence, we've got a cable connection. Also, the biggest next thing is that I spoke to the Airbus guys, many people on Discord, and previous builders of the SMD PCB. Well, it's a lot of waffling just to get into the build. Sorry, guys, we're getting there. Right, biggest problem, USB port getting ripped off and the board becoming useless. Now, I was really trying to avoid that. Worst case with this cable is that you're going to break the cable and the board is still usable. There's no fiddly SMD soldering. There's no fine traces to resolder to repair. Basically, the cable should break before the board does. Hence, it's why we're using a cable. Before you can build the PCB, you need to get a few items. Now, the PCB from myself, you need to purchase. PCB is quite expensive. It is the most expensive PCB that I have created to date. Why is it expensive? Wow. It's because we've got the Arduino mounted on board. It's not an Arduino, it's a Raspberry Pico, but it does the same job. So basically, we haven't got to pay for the Arduino. It's just a straight USB connection. All the components are SMD pre-mounted by JLC PCB. All the buttons. Now, these are high quality, expensive AUX buttons. I use these because of the feel. I went to press the wrong unit there. All the LEDs are mounted. Now, these are super bright LEDs. Why are they super bright LEDs? Because they don't need to be this bright. It's as if you use a filament printer to produce the buttons rather than my buttons. You need to make them a lot thicker, so you need a lot more light to shine them through to get the same effect. So we've basically covered as many scenarios as possible using one PCB. If you're wondering, I had to go through 12 revisions to get the PCB to this state to make sure it was fully capable and to remove all my errors, obviously. Apart from the PCB, you need a 5-inch LCD screen, a power supply 12 volt, preferably 2 amps or higher. I'm using this little brick here. It is rated at 2 amps. The LEDs, now this can power the screen and LED. You just need to split the wires off however you want to do that. I'm going to explain how I'm going to do it in a bit. You need a USB cable. Now, these are dirt cheap off eBay, and they already come pre-coloured and pre-soldered at one end, just to attach to the PCB. I think they're 50p a go. I'm going to use this barrel jack to connect the LED lighting to the power supply in this version only. And you're definitely going to need a 12 volt PWM dimmer. This is going to allow the lights to dim correctly all the way down without them flickering. Love these black ones from Amazon, much better. Now all these parts can be found in the build guide online. Just go through and basically there are links on there if you want, but don't forget, if you click those links, we get a kickback from Amazon as well. Amazon, not Amazon, eBay. Now all these parts can be found online very cheaply from other sources like AliExpress if you're willing to wait a few weeks. With all that waffle said, let's get into the build. We've got our PCB. In the top right corner here, we have the 12-volt power connection. And to keep things simple, I've got this 12-volt barrel jack. You don't need to use that. On previous versions, I just wired straight into the board. But for this demo version, I'm just going to use this barrel jack into the board there. And what we're going to do is bring close cam in. I'm going to strip the wires. There's one. There's two. Give them a little twist. So we flip the board over and now we can just solder those 2 points in. And we are definitely going to give them a trim. Nice. Just going to touch up the other end now to make them a nice little, there we go, little solder balls. And there's our solder connection there for the backlighting, 1, 2. Nice little solder balls. Make sure they're not touching together so they can short. I can't express to you how important the polarity, to get it right first time, it is. There is no reverse polarity protection on this board. So if you were to get these the wrong way around, you're likely to blow all the LEDs. Now that is 2 of the 6 connections done. We've only got the USB cable to go in here, and that's our connections to the board done. Let's grab our USB cable and get that soldered into location. That is our PCB all done, ready to be tested. Now we can test it indeed. So we've got all 5 LEDs showing. That's usually quite a good sign. If we jump over to the computer now and we can talk through what we need to do to get this board working as it is right now. So let me just put the PCB down. We'll re-plug it in at the computer here, if I don't drop the USB cable. There we go, in. So we've got our 5 lights. That's pretty standard because the Raspberry Pico hasn't been programmed yet, and they automatically come on as soon as you apply power. What we're going to do is, here's Mobiflight. We need Mobiflight. Regardless if it's PMDG, if it's Prosim, or if it's X-Plane, we're going to need Mobiflight. So we go to Mobiflight, we go to Mobiflight modules, and you can see that it's showing the Raspberry Pico is connected, but there are no devices, and we need to add those devices. So of course you can add them manually. That's a long-winded way of doing stuff. We've come up with this new way. So we go to the website. There it is. Let's bring that in. Let's expand it to full screen. Let's go to build guides. Go to 737 build guides. And there we go. Top left corner is the prototype. We're going to hit let's go. Scroll down. We've done the wiring. We haven't done the LCD. There's the wiring again. Okay. Download the Mobiflight Config module using the link button below. We're going to click that. It's going to go up to the top. We're going to open it. There we go. For me, it's opened on the other screen, so I'll just bring it in. Now, I've already downloaded it today, so it's one of these 2 files here. Let's go back to Mobiflight. I'm going to quickly look over the top of this other monitor. There we go, into our settings. We're going to hit open. And we're going to find that file we've just downloaded into downloads. And it's the MFMC file. And we're going to load up the FMC one. There we go. You can see that it's inserted automatically everything that we require. All we're going to do is hit upload config. So now Mobiflight knows what devices we've got attached to each pin. Hit OK again. Now we've got 3 options. If you've got PMDG, you need to open the PMDG config file. If you've got Prosim, you need to open the Prosim config, and if you've got X-Plane, you need to open the X-Plane config. So back to the build guide on my website. So the first one you can quite clearly see is PMDG. If you open that one, that will download all the config files for PMDG. That was created by Bram. Thanks, Bram, for that. 5.2 is the Prosim, and 5.3, which is not there right now, but it will be very shortly, is the version created by Andrea for X-Plane 12. So for me, I'm Prosim. I'm going to download the link. It's gone to my downloads folder. I'm going to open my downloads folder. There it is. I'm going to go back to Mobiflight. I'm going to have to look over the screen here. Here's Mobiflight, and then we're going to go File, Open. I don't want to save the empty file. We're going to go down to Downloads, which is where I save the file to, Downloads, open the file, and it's called Captain CDU. It's going to load in all the files now for the Captain CDU. So let me bring in my Excel spreadsheet just before we go any further. So these are all the FSU IP offsets that I've used for the Captain CDU, which we called CDU1. And then I've also pre-programmed a CDU2 for the first officer, so you can have both connected with a simple button press. As of right now, okay, so what's happened is when I programmed this, I programmed it on another Raspberry Pi, obviously another FMC board, and it's basically telling us that it was created on this board, but we've got this one attached. So we're going to hit assign, we're going to hit OK, and that's it. This board should be now ready to go for Prosim. It'll be the same for PMDG or X-Plane, depending on which version you've got. All you've got to do is hit run at the top. We've got 2 warning lights on. Must be Prosim's running in the background, by the way. But you can see that we've got the debug box, at the debug window at the bottom here. And if I push a button, there you go, you can see that whatever I press is working. Now that is the board fully programmed. If you've got PMDG or X-Plane, completely ignore this next bit. But if you've got Prosim, you now need to tell Prosim server what offsets we've used for all the buttons, and we do that by going into config, configuration. This brings up this window here, into combine config. The CDU, the FMC CDU, is under navigation and it's under switch. This is going to take a little while to load up as it loads the 277 files required for the switches. If we're going to do the LEDs, they're under indicators. Just give that a couple of seconds to load up. Now, so if we scroll down the list, there we go, you can see that CDU key 1 pushed. When we hit that, we're looking for that offset there, which is 5300.5, decimal 5, and it goes all the way up through the range. And you actually have to put these in manually because I've not figured out an easy way to auto upload into Prosim. You can also see that the CDU2 for the first offset, all the offsets have been entered there as well. And that's why I created the Excel spreadsheet. So there's all the offsets down the list and it tells you what they're connected to. So you don't have to open up each line of Mobiflight and copy them across. You can just enter them in as they go along. That is how easy it is to connect and program the new FMC PCB. Awesome. All we've got to do now is build the unit. So we can close the computer down for a little while, disconnect the PCB and head back over to the filming desk behind me. Catch you there in a second. Here we are back at the filming desk. Here's our PCB, here's our wires. Now let's sort out the backlighting. So as I said, again, the backlighting is attached by cables. Now you can fit 2.54mm connectors to both the data pins and the power lines if you want to use connectors as well. However, I've temporarily used a barrel socket on this version for the backlighting. Here's the male end. So obviously that's going to go into there. Or we could use our power adapter here, put the barrel pin, and you can see straight away, and there we go. That allows us to have LEDs on full brightness, which I do not recommend. There's no issue with it. It's just that normally that's too bright for the buttons and you get LED bleed out through the buttons. Even though these buttons have got 8 coats, this one happens, these new sets happen to be able to cope with it, but that's not ideal because in a dark environment or dark cockpit, that will be actually blinding through the letter fronts, the text. How we get around that is we pull the 12-volt power supply out. We bring in our PWM dimmer. Now this is connected to my desktop workbench. So we're going to attach this barrel jack to the plus and minus of the PWM dimmer. Outside being negative. There we go. Inside being positive. Now we can connect the barrel jacks. LEDs don't come on, but as we increase the PWM or the pot on the dimmer, now we can vary the intensity of the LEDs all the way through to extreme. I mean, that is extreme. All the way back down. And there we go, they're off. Let's head into the workshop and make these parts. So we've got our resin printed frame. This is the upper part. The lower part is still printing now, but you can see we've got all this support on. It's been resin washed, so there's no resin on it. There's just IPA. Let's head inside to the kitchen sink. Helen loves this part. We're going to put it under some hot water, which makes taking the supports off really easy. That's the next job. So now that the water's hot, just going to run the hot water over the supports. And now we should find that they just break away super easy and flush with the surface. So I'm just keeping the water point on the separation point. There we go. And it was that easy. And what we end up with is quite a smooth surface with all the supports removed. And we can just put this on a bit of sandpaper now, flat down, and just give it a quick sand on the back to make it completely flat. This part can go straight in the bin. Here is our painted faceplates. Now I can honestly tell you that there was no need to remove or flatten the support material on the back. That just happens to fit on the PCB without an issue. The same for that frame there as well. So that saves the sanding. Now the only thing you must ensure is that you've got the support material out from the buttonholes. So I found best for this is a flat bladed instrument screwdriver, and let's see if I can get you in here for a good view. So at the base of each hole are 2 support material struts, and ideally what I do is I just run the flathead screwdriver along the end, wiggle it from side to side a little bit on each hole, and always test each hole with a button. They really want to be free to move in and out. So basically, yeah, they want to drop. Now it really does only take a couple of seconds to deburr each hole. And the button, that's it. The button wants to physically fall through the hole. And the reason for this is, if you could imagine that your room heating up and cooling down, the parts are going to contract and you don't want them interfering through their different heat cycles. So make sure they fall through and do that with each hole. Once that's done, the only other thing we've got to do is fit some brass inserts into the holes on the sides. Now they're all M3. Now to insert the brass inserts, we're going to use the tapered M3 brass inserts there. I've mounted it in a long M3 screw so I don't get my hands on the super glue. Just going to apply a bit of super glue to the stud. Going to find a hammer. And we can hold the thread and tap the the top of the screw, and in it goes. I've actually pushed that in way too far, but that will do. And I'm just going to clean the excess super glue off with a wet wipe. They're alcohol wipes, not your bog standard baby wipes. Now guys, don't forget the brass inserts at the side to hold the handle on. They're M3 as well. So for the lower section, we've got 1, 2, 3, 4, 5, 6 brass inserts. And for the upper section, we've got 1, 2, 3, 4 brass inserts. Now we finally get to put this unit together. We'll start with the top section. I'm going to grab my line buttons. There we go. Couldn't be simpler. These just get pushed into the holes. That's them done. Let's put the screen in next. That just simply slots in like that upside down. We could bring down our PCB, feed the ribbon cable through the hole. There we go. Place the unit over the top, and then we need 3 M3 domed head screws to secure it to the faceplate. So I'm going to use M3 by 6mm screws. Now I've just remembered looking it over. That's it together. That is as easy as it gets. All the buttons I can feel work lovely. I'm just pushing them all. So now you see these embossed lines here all the way along. Before you put the buttons in and the PCB in, they need to be painted white with a white paint pen. The paint pen hasn't arrived, so I can't do it. That's going to have to come at a later stage. But as you saw, it's going to be really easy to take apart. It's basically 4 screws. Now, we've got to do the same with the lower faceplate. This has got a lot more buttons. So I'll put the unit to one side. All we do is we lay it down face down, and we get our other 3 packs of buttons. Here they are. And it's just a matter now of putting them in the right hole. We need to bring our PCB back in. And now we're going to slide
the 2 sections together.
There we go. I need some more M3 by 6mm screws just to secure the 2 halves together. So I think what we should do is apply power again and turn up the brightness. Now what I do right now is go through every single button, make sure it presses properly and it doesn't stick. That is an important factor. You don't want that one key that just binds at the end. That's our unit almost done. I did nearly forget the handle. So 2 more M3 screws. Next up, we've got our annunciator captions. Don't forget to take the back off to protect. And that is our FMC finished, ready to be fitted to the single seat, the dual seat, or the 2 cases. So I'm going to show you how the cases work now, but that is a fully working FMC ready to go. A lot of effort went into that. Okay, let's do this. Let's bring in the case. So we've got the angle case next. That's this big black box, prints in one go on a standard size printer of 220 by 220, I believe. Certainly fits the bamboo. So this case has got the M4 brass insert, 6mm long. And we're simply just going to put them in. And I am going to make sure they're just slightly below the surface. Now there's our angle case, completely done. It's finished. That's simple. 6 brass inserts for that. Now we've got the PCB, the LCD driver, our menu board. This is the support bracket that goes inside. You'll see that we've got 4 M4 brass inserts in the outer edges. And then we've got 3 M2.5 tapered inserts in the middle. You'll also notice that there's not one here in the 4th corner. I get asked this all the time, why there's not 4. It's because when you look at the LCD driver board right here, you can see that they've barely managed to get the hole in the board, and the screw head interferes with this component here, which means you can't actually get a screw in that hole, so there's no point putting one in the support assembly. So now I've got some tiny 2.5mm screws. Let's see if we can get these boards mounted. There's one. I'm not going to do it all the way up just yet. Let's get the other screws in first. Now we can mount our menu board. That's just going to sit on top. And we've got some M3 screws to mount this to the board. So before we fit the FMC unit in, the CDU, it's easy to fit the display board. In it goes, and you want the LCD connector to be facing the upper face where the FMC fits. Let's get some of these M4 screws in the side. I guess now it really is time to fit the FMC, and that should be fairly simple. We just feed the wires through the unit and out of the back. Then we open our last bag up, which is the Zeus fasteners. There we go. And this should be a relatively simple task of just lining the FMC up and inserting the screws. So I'm using M4 by 14mm countersunk screws. And there we have it. There's our FMC, fully built with the angled case. At the rear side, all we've got to do is we've got to make sure we connect this ribbon cable inside. Let's bring close cam in. So we've just got to push this ribbon cable into the inboard connector, just like that, that's it. And then push down on the locking bar. That is it, it's that simple. We should be able to now, right here we've got our barrel jack for our backlighting. We can connect that. If I'm honest, I've cut that barrel jack too short in length. It'd have been nice if it came a little bit further out. Also, it would also be nice to have a barrel jack that fitted into the case here, that sat into it. So I'll have to look into that for a future mod. We've got our USB cable, another mod that's required really, and that's so it clamps the USB cable to the case, so you're not putting all that stress on the board itself. So a couple of mods there required. We've got our HDMI cable. That should plug straight into there. And of course now all we need is the 12-volt power supply. And that's going to fit into there. Give it a couple of seconds. The monitor's on. I'm going to head over to the main computer on the right here and start up Prosim CDU. Now, one of the major benefits of Prosim 737 is not only that can we remotely control this CDU via LAN network on any computer without taking the processing power away from Microsoft Flight Simulator, but we can adjust every aspect of the screen to make it fit our FMC perfectly. Now, this is one of the downsides to PMDG. So what we're going to do is, you can see that we've got Prosim CDU loaded up. I'm going to right click and hit Config. I don't want to show the border and I don't want to show the frame right now. I'm going to hit OK. And that now has allowed us, we've got a black screen that we can move around, and I'm going to drag that onto the monitor of the CDU. So away it goes and down it comes. You probably can't see this on the main screen, but I'm going to right click and hit config again. That's brought up the config file, and we're going to now click start full screen, and that is going to maximize it to the FMC screen. It's as easy as that. So if we have a closer look at the FMC screen now, which is definitely unique to Prosim, you can see that the menu title is slightly off the screen at the upper side. The FMC perfectly is aligned. The D-Link is below the notch, and in fact, if I push the FMC button, there we go. Now we've got something to reference. You can see the further we get down, the approach is way out by almost half a button. Prosim allows us to adjust every aspect. So what we're going to do is I'm going to click on the screen, I'm going to right click and go one down to line config setup, or line config mode it actually says. And now I can use the up and down keys, which is actually the U or the D keys on the keyboard. There we go, and we can bring it down into view. I can now push the left side action key button, which is actually perfect on both sides. The arrows and the notches line up perfectly. So I'll go to line key 2, and I actually am just going to have to go up a bit. There we go. That's perfectly aligned. Switch to line action key 3, again pushing the U key to go up. Down now, D for down, one too far. Line 4, pressing the U key again. Line action 5, I'll bring that all the way up to there. Let's do the maintenance one. That's the scratch pad. You can see how low that is. Let's do maintenance. That should be up there on that side, so they line up perfectly. And again, if we push the right bottom line action key, that's the scratch pad. So you can see that's got to come up loads. There it is. Back down. And I'm going to push L for left. That's going to take the whole lot left. There we go. One right. And we can just see that we've got the yellow on both sides. We can actually shorten it by pushing S key. What we can do now is right click and switch off the line setup mode. That switches it off. And now we can check our buttons. Let's go to init ref. Yep, reference, gate all lines up. Not happy with the scratch pad entry, that's way too high. So let's go back to menu. Let's just clear that invalid entry. So that's the scratch pad. We're going to right click on the back screen and line setup mode, and I'm going to move it down again. D for down, just so we can see it. I think that's pretty perfect. Switch off the line config mode, and now let's clear that line. Guys, that's it. That is definitely one of the massive benefits of Prosim 737, being able to adjust every part of the screen so it looks perfect. We have a fully working CDU. What we're going to do now is we're going to create the flat straight case. So we'll head over back to the filming desk and get that going. Now this is the case support for the PCB. Here's our PCB, and they simply slot together. So these are M2.5 tapered thread inserts. Well, that one's just fallen off. I'm not going to use it because it'll be red hot. In fact, what we can do, is I'm going to put this, I'm going to rest it in the hole because it should automatically line up. There we go. And in goes the heat iron. Now we should be able to come in with our PCB and line it up perfectly. I'm using star point M2.5 screws. So that looks good. There's our PCB all mounted in there. As I said, we're not using the fourth hole. That is just solely resting against the plastic. Now we've got to put M4 thread inserts in all these other holes. There we go. We can bring this support in now, place it upside down, and it should go like that. We need some M4 by 8mm countersunk screws just to hold this support to the case. And that is our PCB and support assembly firmly attached inside. Now it was done like this, so you haven't got to print multiple supports for all this assembly. It makes it much quicker to print. So let me bring in the menu board support. We've got two M3 tapered brass inserts. They're going to go into the two holes in the center. And then we need two M4 brass inserts for the attachment to the case. So we can put them in there. And now we're going to place the PCB in and attach it with two M3 by 6mm screws. We can then place the PCB against the case, two M4 by 8mm screws again, one there and one there. Turn it over, and then what we've got to do is we've got to feed our cable through the hole, and yes, we have got to take a few screws out to be able to do that. There we go. In she goes, and that's what it looks like. Turn it back over and put the screws that you removed to get that cable in back in. So looking back right now, it would have been better to fit this board first and then this one. So the real test now is to get the PCB mounted to the back. The only thing we've got to remember is to feed our USB cable and 12-volt cable through the orifice at the top. Plenty of room. We get the ribbon cable with our finger behind it, and we just feed it through the gap between the case and the PCB. There it goes. The case should then sit firmly against the PCB on the side there. We can flip it over and put our replica Zeus fasteners in. What we need to do now is we just need to feed that ribbon cable into the socket, like so. Push the black clamp down, and then everything came to a sudden stop. I was building this frame here live on camera, and I went to open the packet, the second packet, to make a second frame for the demo purposes. And I bought a 10-pack of screens, a 10-pack of driver boards. So the first 5 boards I created, that one, and 2 more behind you there, all used the driver board that you've seen in this video so far. I then opened the next driver board up to find that they're all different. So this has made things a bit complicated. What I've had to do is take the 3 different boards and create a multi-purpose support. So if you can just see on there how many holes are in that unit now, and because all the cables come out in different locations, I've had to put different slots in. That was a fair mission to get that done. I can't believe it. Never mind. This is actually good because now on Patreon, the guys that have been testing this or have pre-bought or pre-ordered the boards already, they've bought these monitors, and many guys have said that they didn't have the same driver boards. Well, I understand why now. It's because there must be multiple driver boards compatible with the screens. And because I ordered a bulk amount, I've got different driver boards that match the same screens. There's still a fair few left in that packet there. Anyway, there's no change to the process. I've just had to change the two supports. So the menu board has now got extra holes for the different size menu boards, and the LCD driver board has got different size holes. I'm going to quickly put the brass inserts into these multiple holes and get back to you. Same size holes, same size brass inserts, just multiple versions of the same one. Here we go. So I think we're back to where we started. Just going to feed the cables through. So I actually think that might be better, because now we've got these cables coming through here. We can mount them on the outside, and we can use a cable tie around these mounts to hold them. So when you pull them, they're not pulling on the board here, but they're pulling on the cable wrap. So let's put the two together. There we go. Feed the ribbon cable through. Let me screw the two halves together, I think, first. So that just leaves our cover to go on, just to tidy the backside up a bit and to make sure that prying fingers can't touch any of the important electronics. Pull the screws, and that is the straight case done. Looks quite tidy from behind. Got access to the quick action buttons, not that you should use them anyway. Let's turn power on. There it is, all lit up. Actually, should be no different from the angle case here. There we go. That's both the units ready to go. And that brings this video to an end. I am really pleased with how these turned out. To be able to create this at home with a pre-built FMC that basically just slots into your 3D printed parts has come a long way. I wanted to make the DIY MCP version, that was such a huge success where people could just add the parts in. Well, I wanted to do the same for the FMC, and this is what we've achieved. We've got the angle case, we've got the straight case, and I just need to update the 737 single seat design to accept this as well. You can see that this monitor is all up and working. As I've only got one HDMI cable out to the main computer, we should be able to, because I've not actually tested this board, is pull out the 12-volt power supply, pull out the HDMI cable. So we should be able to connect our cables up. Let's do HDMI first, just to prove that this different driver board does actually work. That would cause me problems otherwise. Okay, away she goes. Screen flashed. Perfect. Everything still lines up because basically we're still using the same settings on the computer to the monitor. Guys, I think we're going to call it quits at that. We've gone from a pre-made PCB that you can assemble yourself with your 3D printed parts to produce, hopefully what you think and I think is a really good looking unit. Now with a big smile on my face, I think I can say that's as easy as I can make a DIY FMC. Now remember, there's nothing stopping you from using this 737 lookalike FMC on other aircraft within your sim. Because it's based on Mobiflight software, it means you can assign the buttons for anything that you require. So this makes it a very versatile unit. All it takes is a PCB. Now a PCB, as I said, is a little bit more expensive than normal. That's why the STL files are in the build guide and they're all free. For this episode, guys, this is what we've achieved. Until the next project, sim out.